Right, we've already looked at graphing lines using the calculator, so I'm not going to go through all the simple basic steps. You can refer back to that video if you forget any of the keystrokes. I'll show you them, but I'm not going to bother walking you through them every time here. Let's look at how to use the calculator to help us graph functions. We could graph functions by hand, by plugging in numbers for x, getting numbers for f of x, plotting the points and then connecting them. But that's kind of crazy in the year 2020. So we're going to use 1980s technology in order to accomplish that. Turn your calculator on, get to your y equals screen, and plug in the function 1 divided by 2 times x. Remember, this key will give us x, then plus 3. And we want to see the graph. We go to graph. And we can see that we've got a line that is fairly shallow in steepness. And what we need to do is put onto paper, what you need to do to satisfy me that you've done this correctly and understand this picture is to put enough information on paper to convince me of that. And specifically for a graph like this, for a line, I'm going to want 2 points, and one of them should be the y-intercept. So a couple ways to find that. Remember, one is to use trace, and we can see that that's the point 0, 3, which is right there. Or we can go second graph and get to our table, and that will give us 0, 3, and it will also give us as many points as we want it to give us here. 1, 3.5 I'm not really interested in because it's not a whole number. I only like whole numbers. So 2, 4 would be another nice point. 4, 5 there would be right there. We really only need 2 points. A lot of teachers stress that you should have 3. It's a good idea to put 3, but you really only need 2. And then we should fill in that line so that it looks like a straight line and has arrows on the ends to indicate that it doesn't stop there. It goes on infinitely. Okay, let's look at a couple more here. Y equals negative x squared plus 4. Remember, when you want a negative sign, use this guy down here, not the subtraction. So negative x, your squared key is right here, plus 4. And hopefully you've encountered algebra in the past to the point where you know this should be a parabola. The x squared should give us this U-shaped curve, and it does. And it would be nice if we had that top point there, right? That's obviously an important point on this graph, and it looks like it's at 0, 4. If we go to our table, we'll see that 0, 4 is indeed the highest point on that graph, right? All of the other y coordinates are smaller than 4. And let's grab a couple more off there. We've got negative 2, 0 is a nice one, positive 2, 0. We need a few more points for a parabola than we do for a line because it's a little bit more complicated shape. I would say 3 points is enough there. We want one of them to be the vertex, the point where it turns around. And then just make sure that your picture looks like the right shape. I've got to move that because I'm a lefty. Right? Should have that nice smooth curve. And we put arrows on the ends to indicate that that goes on forever. Let's look at a couple more down here. The square root of x minus 1. Okay, so clear this old one out of here. Our square root key is the second function for the squared key. So you want to do second square root. And notice it gives us the square root with little parentheses. What we want to do is trap whatever's inside the square root inside those parentheses. So we would put the whole x minus, right, this key for subtraction, 1, and then close the parenthesis to indicate that's the end of the stuff that's under the square root. And then we go to our graph. And we got something that looks like kind of like a line, but it's not straight, so I don't want your graph on your paper to be straight. It looks like it stops here or starts here, depending on how you think about it, and we can see that in the table. If we go to the table, right, negative 4, negative 3, negative 2, negative 1, 0, those give us errors. Those are not in the domain of this function. So our function actually starts at this point 1, 0, which is right there. And then 2, 1 is a point on the graph. And the next nice one we get is 5, 2. So 1, 2, 3, 4, 5, 2. Right, so that gives us a few points, including the most important one, the one where the graph stops. And then we see it has just sort of a little bit of a gentle curve there. It's going to keep going on that end, and it's going to stop right there. I don't want your graph to go past that point. You should be smart enough and be paying attention enough to see that that graph doesn't keep going through that point. If you do draw it that way, you're being really lazy. You might run into, in MyMathLab, it asking you for domain and range here. So I want to talk about that for a second. It looks like the x coordinates start at 1 and go to infinity. So this would be from 1 to infinity, parenthesis on infinity because it's not a number. And if we're looking at the y values, starts at 0 and goes to infinity. So you might get asked on one or two of these in this section for the domain and the range. I don't know. It's a little harder to do on the calculator screen than it is looking at a picture in a book of a function. All right, one more just to illustrate the importance of the parentheses. Right here, we had the square root of x minus 1, and our graph looks like this. Here we're looking at the square root of x minus 1. So our difference would be, we would do the square root of x, close the parentheses because that's the end of the stuff under the square root, and then subtract the 1. And that's going to give us a similar but different shape. And it's going to be a little harder to see because of where the axes and stuff are, but our table can still help us. Our table tells us that our first point is at 0, negative 1, which would be right down here. Our next one is at 0, negative 1. 1, 0 would be the next one, and then 4, 1 would be the next nice point on there. And we can tell from the graph that the graph stops there and goes on infinitely on the right. Okay, so that's what I expect. A few nice points on the graph, just to show that you know where that graph actually is, and an approximately accurate shape. Does not need to be fine art, does not need to be super accurate. I do not want you to label. I don't want to see this. I don't want to see 1, 0 and then 4, 1. That really is not helpful. It just makes the graph tougher to read. Right, so that's graphing using the calculator.